A dictionary stores your data as entries, each one a key paired with a value, but storing it is only half the job. To actually use a dictionary, you have to walk through its entries and act on them. Python gives you 3 windows into a dictionary for exactly that: keys, values, and items. Throughout this video, we'll work with one running dictionary of student grades that maps each name to a letter grade. Let's see how to visit every entry, how to unpack a key and its value together in a single loop, and what Python will and won't let you use as a key or a value. Start with the keys. Calling the keys method on grades returns every key in the dictionary. It doesn't change the dictionary at all, it just hands the keys back to you. The type it returns is dict keys, a type we haven't met before, and it prints in an unfamiliar way. If that looks strange, wrap it in a list and you get the familiar list of names: Anna, Matt, John, Katie. Casting to a list is optional. Do it only when it makes your code easier to read. The values method works exactly the same way. It returns a dict values object holding every value, which you can also cast to a list. Notice the grades read BA, BA. Values are free to repeat, and here both B and A appear twice. Most of the time though, you don't want keys or values alone. You want each entry, the key and its value together. That's what the items method gives you. It returns a dict items object, and each element inside it is neither a key nor a value on its own. Each element is a tuple that pairs the key with its value. Cast it to a list and the structure is clear. The first element is the tuple Anna, B, then Matt, A, then John, B, then Katie, A. The object itself is not a tuple. Its type is dict items, sitting right alongside lists, tuples, and dictionaries. What matters is that, just like keys and values, it's an iterable, a sequence you can walk through, which is exactly why Python can cast it to a list. One caution before we loop: don't assume an order. Entries come back in the order you inserted them: Anna, Matt, John, Katie here. Never sorted alphabetically, and integer keys wouldn't arrive sorted either. Python has guaranteed that insertion order since 3.7. But the habit that keeps your code robust is not to depend on it. Rely only on visiting every entry. Because all 3 return iterables, you can loop over them straight away. To print every name, write a for loop over the keys and print each one. Out come Anna, Matt, John, and Katie, 1 per line. The real payoff is items because you can unpack right in the loop header. Write for kv in the items of grades. On each pass, Python binds k to the current key and v to its value. So a single line, print the word key, then k, then has value, then v, walks the whole dictionary and prints key Anna has value b, key Matt has value a, and so on. Every iteration hands you both halves of the entry at once, which is exactly what you usually need. Now a challenge. Write a function, count matches that takes 1 dictionary, and reports how many entries have a key that equals its value. The dictionary can mix types. Take 2 test cases. The first maps 1 to 2, 3 to 4, and 5 to 6. No key equals its value, so count matches returns 0. The second maps 1 to 2, the string A to the string A, and 5 to 5. Here the string A equals itself, that's 1 match, and 5 equals 5, that's a second, so it returns 2. The solution follows the counting shape we always use. Start a counter at 0, then loop, test, increment, and return. Loop over the items, so each pass gives you k and v. When k is equal to v, add 1 to the counter. After the loop, return the counter. Run it on the 2 test cases and it gives 0, then 2, exactly as expected. There's a second way that skips items entirely. Loop over the keys and for each key, index back into the dictionary to fetch its value. Write for x in the keys of D, then test whether the value stored at key x is equal to x itself. If it is, add 1 to the counter. Indexing a dictionary uses square brackets exactly like a list. D of X gives the value for key X. You can even loop over the dictionary directly, which also hands you the keys. But naming the keys method is the clear, explicit form. Both versions are correct and both return 0 then 2. Still, items is usually the easier rate because it already hands you a variable for the key and a variable for the value. With the indexing version, you keep reaching back into the dictionary. Dictionaries are mutable, so every rule you learned about aliasing and copying lists applies here too. A plain equals sign never copies anything. It makes an alias. Start with a dictionary named D1, then write D2 equals D1. Now D1 and D2 are two names for the exact same object. Change either one and you've changed that single shared dictionary because there has only ever been one. When you genuinely want a separate independent dictionary, call the copy method on the original, D3 equals D1.copy. That builds a brand new object with the same entries, and now you can change D3 freely without touching D1. Finally, what can actually serve as a key and what can serve as a value? Values have no restrictions at all. A value can be an int, a float, a string, or a tuple. It can be a list. It can even be another dictionary. Anything you like. And the values may repeat, just as our grades did. Keys are stricter in two ways. First, keys must be unique. If key 1 mapped to 5 and also to 6, a lookup would have no way to know which value you meant. Second, keys must be immutable, technically hashable, but think of it as immutable. An int, a float, a string, a tuple, or a bool can all be keys. A list cannot, and neither can a dictionary, because those are mutable. Try to use a list as a key and Python raises a type error, complaining that the type is unhashable. So there are your three windows into a dictionary. The keys, values, and items methods change nothing, and each returns an iterable you can cast to a list or loop over directly. Items is the one to reach for most often because unpacking K and V in the loop header hands you both halves of every entry at once. Remember that a dictionary is mutable, so a plain equals sign aliases it while the copy method clones it. And remember the rules. Any value goes and the values may repeat, but keys must be unique and immutable. Master those, and you can walk through any dictionary with confidence. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.